proteins, because this information or this learning up sa amino acids will also help us in our next topics, particularly in the nucleic acids, specifically when we talk about codons and anticodons. So balik ta atras ta gamay. So na ko gi-post or gi-upload sa tong LMS nga proteins nga file, and I told you last Saturday, if I'm not mistaken, to focus on reading those files nga na protein and enzymes and vitamins. So karon protein sa ta. And as we all know, by definition, no, protein is a naturally occurring unbranched polymer in which the monomer units are amino acids. Okay, we all know that the building blocks of proteins is or are amino acids, and as we all know, we have divided, or the amino acids are divided into two general divisions, di ba? Meron natin lahi-lahi nga mga pag-group or way of grouping these amino acids. But the most common kay divide siya into two. We have the non-essential and the essential amino acid. And before we dig deep no with the amino acids and the proteins, the structure of proteins from the primary, secondary, tertiary, and quaternary structure of proteins, let us be acquainted, or let us be informed that based from our handout, guys, next to water, protein is the most abundant substance nearly in all cells. And this was, although na mga references nga nag-ingon nga carbohydrates, di ba, na-discuss na to na siya before during the midterm nga, in the macromolecules, we have the carbohydrates followed by proteins, and essentially these proteins are numerous. Okay, they are many in terms of number because they do many specific function. So that's one of the reasons why this protein or this macromolecule protein is numerous in or most abundant, is a most abundant substance in all cells, and as they also account for about 15% of cells overall mass. So it speaks a lot when it comes to the number of this macromolecule. Okay, so much for the introduction about protein. I know na naanamoy knowledge about protein because this topic is not new to us, especially that we are engaged in this program in science, and I am assuming also that you love science. That's why you're here and enrolled in our program. So this topic, actually, the topics that are under our course is not really that new to us. Some of the topics are very obvious na kayo, or kabalo na gid kay ta ni kung unsa ni sila nga mga topics, but we need to review lang or to dig deep pagyud sa mga naaani niya nga mga topics. And so we will start with the non-essential and the essential amino acids, as these amino acids are the building blocks of our protein. So by having that the understanding kung kinsa si amino acid, hopefully we can also build an understanding on how proteins behave and the functions of this macromolecule. Okay, may I call Mr. No, this is not Mr. May I call Larlene Argilies? Na ba siya? Argilies? Or si Baguhin na lang? Kay Baguhin. Uy, di man mamaningog lagi. Asa naman natong interactive ani nga pagka-klase. Okay. Si Casas na lang. Casas. Lapod? Okay, let's have Martinez.
Yes, sir. Good morning, sir.
Okay. Good morning. We have two major divisions of amino acid, right? We have non-essential and essential. Can you enumerate the non-essential amino acids?
So the non-essential amino acids are the alanine, arginine, asparagine, aspartic acid, cysteine, glutamic acid, glutamine, glycine, proline, serine, and tyrosine po, sir.
Okay. Okay, that's correct. We have alanine, arginine, asparagine, aspartate, cysteine, glutamic, glycine, ornithine, proline, serine, and tyrosine. We have 11 non-essential amino acids, and as what we have, or as based from our discussion before, we call them non-essential because our body can synthesize or can make these amino acids, or these amino acids are already present in our body. So there's no need for us to intake food nga nag-contain ani nga mga amino acid. Okay? And since 11 man siya, and the total amino acids that we have in our body kay 20, we have the essential nga na 9 kabuok. So may I call Camino to enumerate the essential amino acids. Christopher Camino. Na si Christopher. Okay, let's have Morado. Yes, Morado.
Sir, good morning, sir. So the essential amino acids are valine, isoleucine, phenylalanine, methionine, threonine, tryptophan, histidine, arginine, leucine, and lysine, sir.
Okay, thank you. Recap lang, we have histidine, isoleucine, leucine, lysine, methionine, phenylalanine. We also have the threonine, the tryptophan, and the valine. Okay, mo to sila ang atong mga basic nga mga, or mo to sila ang building blocks sa atong protein or the amino acids. So later on, I would like you to memorize this one because later on natay activity for the amino acids alone, and try to memorize as well ang ilahang kuan short name or ang ilang abbreviation. For example, unsa ang abbreviation sa name ni alanine, the histidine, ni isoleucine. Okay, so you try to include that in your readings as well. So you find the reference kung, or naman ni siya diri sa to ang siya sa to ang handout nga gihatag nako. So again, i-appeal na siya sa inyohang pag-study. Okay? So we already knew or know the major divisions of amino acids, and as we all know, amino acid again is an organic compound that contains both the amino acids and the carboxylic acid or the carboxyl group. So that's why amino acid, it has amino or amines, the amine group, and then it has the carboxyl group. And then, based from our handout, the amino acids found in proteins are always the alpha amino acids. And when we say alpha, it's an amino acid which the amino group and the carboxyl group are attached to an alpha carbon atom or the R group. So, natay ginatawag na side chain. We also have the amino group and the carboxyl group. The side chain there is the R group. So, remember lang ha na ang R group is the side chain, and then we have the carboxyl group and the amino group. And if present na siya sa structural or the skeletal formula of a particular compound, so pwede na to siya immediately matawag na amino acid. So depende na lang kung depende siya sa iyang R group kung kinsa siya nga pagka amino acid. And we have this standard amino acid. So when we say standard, these are the 20 amino acids nga atong na-identify kanina, like the 11 non-essential and the 9 essential amino acids. So we have, aside from sa pag-group nato sa amino acid in terms of being unessential and in terms of being a non-essential amino acid, gid na po siya another division sa ang mga amino acid. We have the non-polar amino acid, we have the polar neutral, the polar acidic, and the polar basic amino acid. So let's start with the non-polar amino acid. Okay, I want Sebil to give his insight about the non-polar amino acid. Sebil, what do we mean by non-polar? So masabta naman na siya sa tong handout. So you give your own insight out from the text na pwede na mo mabasa sa atong handout. Ken Paul?
Yes, sir. The non-polar amino acid. These are the amino acids that are long carbon chains or carbon rings, making them bulky. So this includes alanine, mucin, isoleucine, proline, tryptophan, valine, and phenylalanine, and methionine.
Okay, when we say non-polar, what does that word mean? So man ang ginamean when we say non-polar? I am talking to Sebil gihapon ha. Say Sebil gihapon. Sebil, when we say non-polar, unsa ang ginapasabutan na? Is it water-fearing or water-loving? Unsa man ang gina-entail nga definition when we say non-polar? And it gives us an impression kung usa di ay ang behavior ani nila nga mga amino acid katay mong gingon ganina, like we have the tryptophan, the methionine, and other non-polar amino acids. Sige daw, Ken Paul?
Ang non-polar, sir, kay monit po siyang mga molecule nga soluble in water or ma-mix sa tubig.
Are you sure, Sebil? Anyone would like to support or disagree sa answer ni Ken Paul? Yes, Mylene?
So when we talk about non-polar amino acids, sir, they are kanang mga water-fearing, meaning to say they repel in water po.
Okay, and then? That means they are not attracted to water molecules. So
Sure.
the behavior is they don't mix with water, or they can't be they are not soluble sa water. So that's one of the behaviors na pwede nato ma-associate when we classify amino acids as non-polar amino acids. Okay, so again, ang example ni Sebel kanina, we have the tryptophan. So yeah, it's a member of this group because water can weakly interact through hydrogen bonding. So that's correct. Ang timanan lang when we say non-polar, these are the amino acids nga water-fearing or hydrophobic in nature. So that's the first group, or that's the first category where we can classify amino acid. The first one, the non-polar. Next, we have the polar neutral amino acid. Tating, can you share what a polar neutral amino acid is?
A polar neutral amino acid, sir, contains amino group, one carboxylic group, and a side chain that is polar but neutral. It is neither acidic nor basic. So, a polar neutral amino acid from the word polar, it is a hydrophilic, and there are 6 polar neutral amino acids. These amino acids are more soluble in water, sir.
And then, is that all, Tating? Moro to?
The R group, sir, is present can hydrogen bond also to water.
Okay, that's correct actually. So the structure, again, we go back to the structure of an amino acid. No, it has a side chain, and we have the amino group and the carboxyl group. when it comes to the polar neutral, ang tamang giingon kanina that the side chain is polar but it is neutral. So meaning its pH is, what is the pH when we say a substance is a neutral substance? What could be the pH of that substance, by the way? Tati?
7, sir.
7, sir.
Okay.
Either acidic or
Taga nagtating ay, pero okay lang. It's 7, exactly 7. So meaning the pH level of a substance that is a neutral substance is exactly 7. Okay. So again, gingon ako ganina that the major indicators sa behavior or sa classification of a particular amino acid is its side chain. So, pag ang side chain, timana na to kay polar, pero dili siya basic, dili po siya acidic, automatic, polar neutral. Pero if ang side chain is non-polar, then it is under non-polar amino acid. So, ang ato lang tanawon when we will try to investigate or to try to understand the behavior of a particular amino acid is ang iharag yung side chain. Next, we go to the polar acidic amino acid. Miranda? Andrea Jean?
Yes po, sir. When we say a polar acidic amino acid, sir, kay muna siya ang amino acid na nag-contain siya og one amino group og two iyang carboxyl group, and then ang iyang backbone sa amino acid, sir, kay polar siya, sir. Polar or basic siya, which is water soluble, and basic, when we say basic siya na amino acid, sir, is yung pH level is 7.1 to 14 po, sir.
Basic, we are talking about polar acidic ha. Dili pa ta polar basic. Polar acidic. Miss Miranda.
Ayos.
Sige. O, saba. Rewind.
Sige, sir. Ang polar acidic amino acid, sir, is mo na siya ang naga-contain siya og one nga amino group tapos two ka carboxyl group, sir. And then, ang second na carboxyl group, sir, kay part siya sa side chain niya, and then sa iyahang pH level, sir, sa side chain, sir, is acid siya, sir, which is negative charge.
Tapos, example? Can you cite an example of a polar acidic amino acid?
Aspartic acid, sir.
And then,
O glutamic acid.
okay. So, polar acidic, okay, again, the basic structure is still there. We have the amino group, and then the difference is nala siya two carboxyl group, and then the second carboxyl is being part of the side chain. So, this side chain is acidic, therefore, kasi, again, the side chain will determine the behavior of a particular amino acid. So, duha siya ka carboxyl group, but the second carboxyl group is considered as the side chain. So, again, in terms of structure, complete gyapon. Makonsider gyapon siya nga amino acid because it has the side chain or the R group, which is the second carboxyl group. We have the first carboxyl group, and then we have the amino group. Okay, and the last category for the four categories under amino acid is the polar basic amino acid. Yes, or Danisa, would you like to share something?
For polar basic amino acid po.
Yeah.
Okay, for polar basic amino acid, so it contains two amino groups and one carboxyl group. So ang second daw na amino group is part of the side chain. And ang side chain niya is naga-bear siya og positive charge. And then ang nitrogen is accepted sa proton. And ang iyang pH level, since basic man siya, is 7 above. And ang iyang example is lysine, arginine, and histidine po.
Okay, that's correct. ang major difference lang nila sa ni polar basic and polar acidic and polar basic is kang polar basic timanan lang nga duha iyang carboxyl group, but the second carboxyl is part of the side chain, and then for polar basic naman duha iyang amino group and the second amino group is part of the side chain. So baliko na to guys, that we have the non-polar amino acid in which the side chain is a non-polar substance, so meaning it is hydrophobic or water fearing. We have the polar neutral, wherein the side chain is polar but it's neither basic nor acidic, so that's why it's neutral. And then for polar acidic naman, duha ka carboxyl group in which the second carboxyl group is part of the side chain and there is one amino group. And for polar basic, duha iyang amino group in which the second amino group is part of the side chain and then there is one carboxyl group. Okay, so moto siya ang 4 categories aside from the major division of amino acid. Separate ang essential and non-essential sa kani nga mga category. So you will also memorize the amino acids under each category. So aside from the non-essential and essential, each category po naman po sila mga underlying na mga amino acid. So i-memorize po ito ninyo guys. Okay. So, it's good to know na kabalo mo or nabasa ninyo karon, kaya basig wala niyo gibasa. And it's good to note also nga when we say protein, the major elements that can be found in the protein, we are the carbon, hydrogen, oxygen, and nitrogen. Okay, so mo sila ang mga basic gyud nga mga elements that can be found in the protein. Okay, again we have the carbon, hydrogen, oxygen, nitrogen, and sometimes there is the presence of sulfur. Nana ang presence in nitrogen, since we are talking about mga amines. Okay, so I know familiar naman sa amine as an R group, no? Kauban nila ester. Okay, kauban nila ether. So amine, mga amino group mo na sila. Amine or amine. So sa akong other nga teacher, no, they pronounce amine as amine, pero regardless or either way pareha naman nag-meaning. So it could be amine or amine. So mo na presence ni nitrogen. So sa next page we have here the amino acids that can be or that are under the non-polar, the polar neutral, polar acidic, and the polar basic. So nana po diri guys ang ilahang mga abbreviation. For example, kay glycine, so we have the GLY. For alanine, we have ALA. So kamo na lang mag-memorize ani. So again, memorize ang non-essential and essential amino acids along with the non-polar amino acid, polar neutral, polar acidic, and the polar basic. Okay. So sa next page po, makita ninyo nga natay chirality and amino acid. So ang chirality na-discuss na nato ni siya during sa atong topic sa carbohydrate, and I am hoping na wala niyo ito nalimtan. Kung unsa ang chirality, we have the achiral and chiral nga mga molecule, katong mga mirror and all of those concepts. So same lang gyapon to siya o same lang gyapon siya diri sa to ang discussion when it comes to amino acid. Okay, so let's start. Let's continue sa discussion sa acid-base properties of amino acid. So in pure form, mabasa na to here that amino acids are white crystalline solids with relatively high decomposition points. Again, in pure form, amino acids are white crystalline solids with relatively high decomposition points. So mo lang siyang importante diri sa acid-base property. And then we also have this zwitterion or the zwitter ion. So again, sa akong mga other nga mga chemistry teachers, aside from sa DNS nga chemistry teacher, ang among pag-pronounce, nagkabikil-bikil lang pag-pronounce ani, na zwitterion, na po zwitter ion. So, zwitter ion siya in the same way that we pronounce cation as cation, dili cation, di ba? Or not anion, the anion. So, pero pwede na na siya nga zwitterion or zwitter ion. But ang ato lang importante nga manumduman or mahibalan when we say zwitter ion or zwitterion, it comes from, or ang yang literal translation is double ion. So, meaning it contains a positive charge or a positive ion and then a negative ion. Pero the totality of the in terms of net charge, wala gid siya, because when we kanang kunta ibangga nato ang duha ka ions niya, it can constitute a neutral charge. So again, timanan ninyo nga when we say zwitterion, double ion siya pero ang net charge is 0. Please, ayaw ni kalimting nga concept because mugawas siya sa let. Nigawas na dahil siya, di siya mugawas. Nigawas na siya. Although sa among time, last March, wala siya nigawas, pero mugawas na ni siya, or nigawas na jud. And the reference nga kung gihatag sa inyo kani siya, it comes from a Filipino author nga mo ni ang paborito gamiton sa PRC. So nataan nga reference, so i-maximize nato ni. Ayun yung kalimti, tanang ginahimo nato guys, na siya relevance later on. So again, when I say zwitterion, double ion, but iyang net charge is 0. So if you are to be asked what type of ion has a 0 net charge, automatic na answer is zwitterion or the zwitter ion. Wala na siyang importante. And then, skip na ta. So at least no, kung wala man mo nakabasa karon, naka-scan mo gamay. Okay. We also have here the isoelectric point. So when we say the isoelectric point, it is the pH at which an amino acid solution has no net charge because an equal number of positive and negative charges are present. So dili lang ma-confuse no sa mga definition. Ang timanan lang yun, most of the terms in science nga naay iso, equal yun na. For example, in an isotonic solution, usually equal na siya. Diba? We have the hypertonic, the hypotonic, and the isotonic solution. Ang isotonic yun, ang timanan yun, equal yun na. Ang kanag yung iso, murag ko, kambal na siya sa word ni equal. So ingana na lang atong pag-understand because more on ang biochem good is more on memorization lang siya, more on mga factual na mga concept, pero kung di na to siya isulod gyud sa tungotok malimtan ra man gyud siya. So just like in the zwitterion or the zwitter ion, another concept kung di na to siya masulod gyud sa tungotok malimtan na gyud siya. But take note lang yun when we say isoelectric point or any term in science nga na iso, it is usually ang yung translation or yung meaning it is equal, or kung equal yung charge, meaning 0 gihapon yung net charge. Okay, so malang timanan when we say isoelectric point, it is the point where there is a 0 net charge, because again, iso means equal, so there is an equal number of positive and negative charges. So that's why 0 net charge. So ang point ni isoelectric point. We also have here electrophoresis or phoresis. Electrophoresis. So it's simply a process of separating charged molecules on the basis of their migration toward charged electrodes associated with an electric field. So remember lang, when we say electrophoresis, it is just a process of separating charged molecules. So ana na lang siya. Okay, so again, balik ta sa isoelectric, na equal number of positive and negative charge, therefore it has a 0 net charge. And then electrophoresis, it is a process of separating charged molecule. So, mao lang to siya, guys. Next is kaning cysteine as a chemical unique amino acid. Dili na kay nato ni idig gyud kay ma-memorize man yun yung cysteine. So, anyway, ang atong style ani is dili man kahit mag skeletal gyud nga formula or structural formula gyud sa mga amino acid, pero mas maayo lang gyud nga kabalo. Pero kani pwede ra ninyo nibasahon ang cysteine as one of or as a unique amino acid. So focus ta sa mga peptides or sa peptides. So based from the definition, peptide is an unbranched chain of amino acids, each joined to the next by a peptide bond. So if ang amino acid kay dili siya ma-connect no sa iyang target na connectan, pag mo connect siya sa another amino acid, for example, if tryptophan will connect to phenylalanine, then peptide na siya, or it is bonded by a peptide bond. So mora na siya because again, peptide is an unbranched chain of amino acids or an unbranched chain of amino acid. Yeah. Unsa di ay nganong kailangan man siya ma-branch, because again in our discussion with the nucleic acid, connected ang mga amino acid po dito and then we have because daghan og connection man gud siya tanan. So kung dili siya ma-connect sa target gid nga connectan ang amino acid, so mo-consider siya as an unbranched chain of amino acid, and pag mo-connect na siya sa mga other amino acid, then it's called as a peptide. And then a polypeptide is a long unbranched chain of amino acids, each joined to the next by a peptide bond. So we have ang atong ginaiskutan rin ng mga bonding is more on hydrogen bonding, and this hydrogen bonding is connected also with the peptide bonding or the peptide bond, because if ever na dili sila sa carbon mo connect, they can connect to the nitrogen or to the carboxyl group. Okay, and remember that trivalent si nitrogen, meaning capable siya of a triple bond. Like sa oxygen po, divalent siya, so it is capable of a double bond. So pwede siya dito mo connect kung na may excess nga hydrogen in the chain. Okay, so pwede raman nga isa lang sa ang mo-connect ang nitrogen, pero it's capable of a triple bond. Like in our carbon, tetravalent, so capable siya of 4 nga ka-bond. So pwede siya maski asa. So dili gyud siya more, pero ang bottom line lang is hydrogen bonding gyapon siya, pero specifically in this context we call it as a peptide bond. Okay? And then, so a peptide bond is a covalent bond. So when we say covalent, ang sa ganitong covalent, it's just sharing of, sa ilang gina-share, nag-share lang sila og bonding. So kung nagdili siya charged, pero ga-share lang sila. So ga-pair lang sila. When we review our previous knowledge about the Lewis dot structure, so that's how we can fully understand bonding in general. And then tama mo to siya ang sa Lewis dot structure. Okay, we also have here amino acid residue. So it is a portion of an amino acid structure that remains after the release of water. So when an amino acid participates in peptide bond formation as it becomes part of the peptide chain. So from the word residue, so salin lang siya guys after na ma-release ang H2O or ang water. So pag naay release of water, ang mabili na ng amino acid is being called as amino acid residue. Just like when we decalcify a particular, when we say decalcify, we try to extract a calcium sa bones, for example. So ang remain is called a residue. So in the context of amino acid, when we try to eliminate water or to dehydrate a particular amino acid, then it's being called as amino acid residue. So same concept lang yapon. Again, when we try to decalcify bones, okay, ang process nga pagtanggal sa calcium sa bones, then ang nabilin dara sa bone without calcium is just the residue. And in the context of amino acid, when we try to dehydrate a particular amino acid, then ang tawag sa nabilin is amino acid residue. So that's basically what amino acid residue is all about. So we have here the peptide nomenclature. Are you familiar with the IOPAC? What does IOPAC mean? Dapog. If you familiar pa ba maning IOPAC? Sino? Dapog, Mary Grace?
Kalimutan ko sa abbreviation.
Mary Grace, are you there? Yes, Mary Grace.
So, ang ayupak, sir, kay katong short term sa name sa isa ka sa ito siya band banggo to, sir, sa chemical ay sa
Are you
ay kuan ni siya,
sure?
sir, sa ang iyang kuan ani, sir, kay acronym kay kuan International Union of Pure and Applied Chemistry, sir.
Okay, that's correct. So, IOPAC is somehow an agency or an office that is responsible of naming our elements or mga elements and underlying chemical nga mga things, no? Either in our environment or in our body. So just like in your inorganic and organic chemistry, you can hear the word IOPAC sa inyo pong periodic table napoy IOPAC nakabutang. Here in biochem napote IOPAC. So particularly it's more on the nomenclature or the naming of a particular substance. It could be an element or it could be a substance being attached to a chemical or chemistry related nga mga substances. So apil na siya sa trabaho ni IOPAC, or basically IOPAC is just like the taxonomy of chemistry or the taxonomy in chemistry. So naming of compounds, naming of materials, naming of substances, in which this taxonomy is being introduced to us by Carlos Linnaeus, right? So in your basic biology. So ingana somehow similar ang ilang mga trabaho or ang ilang mga purpose. Okay, so we have here the peptide nomenclature, we have the rules, and you need to be familiar with these rules. Familiar lang, dili necessary yung memorize. So the first rule is the C-terminal amino acid residue. So meaning to say the amino acid residue katanan ni siyang dehydrated or gi-withdrawn na to ang water molecule, it keeps its full amino acid name. And in the rule 2, all of the other amino acid residues have names that end in Y, and the Y suffix replaces INE or ic acid. So for example, we have the histidine. Okay, so nag-end sila og Y pero gi-replace na siya og INE. So just like also in our alanine, so money ang diri na sila na under. Like for example, in our cysteine, so cysteine, the glutaminyl or the glutamine. So mo lang ang rule. And the third rule is the amino acid naming sequence begins at the N-terminal amino acid residue. So more on the nitrogen area, dito mag-start ang sequence because again, ang purpose lang ni R group or the carbon group, because the R group or the side chain, mamanto siyang carbon group apart from the carboxyl group. More on the characteristic to, yeah, but the naming dito siya sa amino group or sa N-terminal amino acid residue or sa amino group. Okay? So remember lang na ang reason or ang purpose nganong naay presence of carboxyl group sa amino acid is para matawag siya as an acid, because remember that a carboxyl is somehow related to carboxylic acid, and the R group or the side chain is responsible for the characteristic of that particular amino acid kung asa siya naka-attach, and then for the terminal group or the N-terminal group or the amino group, it's more on the nomenclature or ang pag-name na karon ani nga amino acid. So, mo to yung timanan, guys. Okay. I think mag-proceed na ta with the structure of protein. So, we have 4 structures of protein. We have the primary, the secondary, tertiary, and the quaternary structure. So, mag-ask ko kang Petalyar. Petalyar, can you tell me what is happening sa protein during the primary protein structure? Unsa ang nagakahitabo inside or sa protein itself pag napa siya sa primary structure? Kian?
In the primary protein structure po, it involves more than just the numbers and kinds of amino acid present. It also involves the order of attachment of the amino acids to each other through peptide bonds po, sir.
That
So,
means,
in additional po, sir, ang primary protein structure is the order in which amino acids are linked together in a protein po, sir.
that means, so, in short, unsa di ay ang may tabo or unsa ang simple or simpler explanation para mas dali nato siya masabtan nga pag primary protein structure mao pa ni siya, dili pa di ito siya mao katong 3D model na siya. So unsa man ang simpler explanation when we say that a protein is still in its primary structure, Kian?
Kanang ang koan, sir, ang kaning tawag ni po, ang amino acid or ang say in H3 or the amino acid is koan, sir, kanang naka-order, naka-attach siya in orderly sa mga peptide bonds po.
Tapos, sige, how about the others daw? Ano si Ellie Garle? Would like to share pa daw additional information? Okay, si Nipes.
Yes, sir. Good morning.
Sige,
Sorry ta
additional...
kung tingog third time or agi obo jud ka, sir.
Okay lang, laban. Sige, additional information about the primary protein structure.
So, based on my prior knowledge about the primary structure, sir, kay it is the simplest level of protein structure, or the primary structure is simply the sequence of amino acids in a polypeptide chain po. For example, the hormone insulin has 2 polypeptide chains, A and B. Muna siyang example, sir, sa ako ang base, ako ang nasabtan last sa primary structure. That's all po.
Okay, thank you very much. How about Caminero? Caminero Giselle? Sige daw. Caminero, are you there? Ano ba siya? Or let's call Sibalios na lang. Sibalios. Sibalios. Hello guys. Asa naman eh? Sige. Tama ang mga answer guys actually that when we see primary protein structure, simple or simply nag-align lang yun ang mga amino acids. So, ang endpoints nila or ang ilang terminal points are the amino group and the carboxyl group. So, and this chain of amino acids based from our previous nga nanisgutan ganina is the peptide or the peptide chain. So, these are unbranched amino acid nga gi-connect sa mga another amino acids, and then karon nga gisulod na nato sila sa mga terminal points in the amino group and the carboxyl group. This is now the primary protein structure. So again, when we say the primary protein structure, simply nagline lang yun na siya ang mga amino acid. Just like amino acid protein structure. Okay, madungog pa ko.
Putol-putol ka,
Hello,
sir.
everyone.
Pilit ka, sir.
Putol-putol, sir.
Sige. Hinihinay yung internet diri, ano just siguro ni. That's life. Pero again, balik ko na to ha. So, in other context na in the PMAT, na again, na-point na nga, nagline lang yun siya before siya mag-separate, before siya mag-create og daughter cells. So, ingana po sa primary, in the proteins nga, when amino acids line up, so basically, that's the primary protein structure or the primary structure of protein. So, nga lang, tibanan na ito, pag mag-line na sila, if nanay sequence of amino acid nga na-form from the terminal points from the amino group down to the carboxyl group, then that protein is still in the primary structure or in its primary protein structure. Okay, let's proceed with the secondary structure or the protein secondary structure. May call Sibelius. Tapos Sibelius. Sige, ano na lang. Cerezo. Secondary structure. So kung nagline ang primary, unsa na karon ang mahitabo sa secondary protein structure? Cerezo? Sa naman ni, dili na maningog or dili na ko madungog. Sila kung madungog ko pa, Grace dumughan tanan. Okay, nadungog chud ko. So wala lang nito bagang uban. Okay, si Jessica na lang. Ay, sige, si Rezo.
So sa secondary protein structure, sir, which is the arrangement space adapted by the backbone portions of a protein, sir.
Tapos, si Balios, wala ko nang tanaw sa akong cellphone. Sige lang. Okay, moro to,
Then
Danley.
go on, sir.
Sige
The
daw.
type of interactions responsible for both of these types of secondary structures, sir, which is the hydrogen bonding between a carbonyl oxygen atom of a peptide linkage and the hydrogen atom of an amino group, another peptide linkage.
Okay, tapos, moro to.
Yes, sir.
Okay, how about Suarez? When we say secondary protein structure, unsa ang noun sa protein after siya mag-line, pag nana siya secondary structure. Sige daw.
Hey, sir, good morning once again. So, when we talk about the secondary, based on my understanding of this structure of protein, sir, it is actually, if the primary structure is linear, this one provides a planar naman, sir, na planar naman na structure of the protein, sir. So, ibig sabihin, sir, there is now an association, based on my understanding, there is now an association of other, there is a linkages between amino acids na makagbuo siya og secondary structure, sir.
That means when we say planar, what could be the common arrangement of the amino acids and the secondary protein structure? Ronel.
Okay, sir. So when we talk about a planar, sir, kanang mura siya kanang naka-cross na good, sir. Like, yes, sir. Parang naka-cross na. So like a plane, sir.
I mean, what is the most common types of the plain structure of the secondary protein structure?
According to the handout, sir, we actually have here tong mga sa to siya eh. Dara, sir. We have here the most common na mga secondary structure is yung mga alpha. Yes, sir. Itong mga
Alpha.
yes, yung mga helix structure, sir, yung mga ganyan po. Mga alpha helix, mga beta pleated sheet that are actually
Okay? Okay na ta?
yes, sir.
Okay. Actually, that's correct, no? In the primary protein structure, they are arranged, no, either linear or in any form, basta kay nag-line up lang yun sila. So, pwede sila naka-zigzag, basta kay line lang, one dimension, naka-line lang, plain lang na line. But in the secondary structure, they form planar structure, particularly alpha helix and a beta pleated sheet. So, mo lang gid ang bottom line or ang point when we say secondary protein structure. Ang may tabo lang gid is the formation of the alpha helix and the beta pleated sheet. So, pag pangutanan mo what could be the arrangement of the amino acid in secondary protein structure, in the secondary structure, alpha helix ang ginang itubag and beta pleated sheet. So, wala lang answer, alpha helix and beta pleated sheet. So, mana siya ang common or mana siyang gahitabog yun during the secondary protein structure. So, that's it. And then when we say alpha helix, we can read here. So it is a protein secondary structure in which a single protein chain adopts a shape that resembles a coiled spring or helix, no, from the word helix. So the same with our DNA. So in a helix form. So it could behave or it could form as a helix, just like the alpha helix structure, or pwede po siya beta or the beta pleated sheet. So in the beta pleated sheet naman, it is a protein structure in which two extra protein chain segments in the same or different molecules are held together. So meaning dili na lang gid sila plain lang nga nakalinya or linear or naka-line up ang mga amino acids. So they form either helix or as a pleated sheet. So that's the point when we identify or when we try to describe a protein in its secondary structure. So if naka-line lang or nag-line up lang ang mga amino acid during the primary protein structure and naka-form og mga alpha helix and beta pleated sheet during or in the secondary protein structure, what could be the arrangement or behavior of the amino acids in the tertiary protein structure? Okay, Giselle Caminero. Giselle. Saan naman ni? Saan naman ni? Dili naman lagi maningog. Corvin. Tertiary protein structure. Uy, naunsa naman ni? Di naman ni maningog. Lagi.
Yes, sir.
Sige, Corvin.
So, my question, sir.
Tertiary protein structure. Unsa may tabo sa amino acid or unsang behavior or arrangement.
Sa tertiary protein structure, sir, is na 4 types of bonding and bonding interaction between the side chains, including the hydrogen bonding and the salt bridges, sir. And
Unsa may ang arrangement or formation. Okay, how about Hiroche?
Ako, sir. Actually, proteins of three-dimensional shape of a protein that results from the interaction between amino acid side chain or the carbons that are widely separated.
Saba lagi mo audio. Sige. Sige, unmute sa mo guys. I mute sa mo. Sige. When we say tertiary structure, basically, naka 3D lang siya. So, tertiary, 3D. So, mo lang yan timanan. 3D ang iyang structure. So, for example, if nag-helix na siya sa secondary structure niya, then sa tertiary structure is 3D na siya nga helix. Or kung nag-pleated sheet siya, katamurag zigzag na naka-planar structure, then 3D version na siya pag-abot na karon kang tertiary structure. And it's the same way gihapon sa or it's the same nga behavior or nga structure sa quaternary. Naka 3D lang gihapon siya, and it consists 2 or more independent peptide chains. So murag fully developed na siya. So kung sa tertiary is naalan siya overall 3D or 3-dimensional shape. So ang sa quanagyud is sa quaternary is fully developed na gid siya nga 3-dimensional shape of protein. So ang analogy nga pwede nato magamit to understand the structure of protein, actually napot siya sa handout, is the telephone wire. So kung yung nang binato ng telephone wire, linear or nakaline, that's actually or that's the primary protein structure. Pag naka-steady lang siya or binato na lang siya nga dili kaayo siya totally nga binat kana ma-emphasize gyapon ang iyang mga curls or the helix niya nga formation. So that is the secondary protein structure. So kung imo lang siyang pasagdan as it is 3D, so that is tertiary protein structure. So if fully developed na siya, later on, a protein can now be considered in its final structure in the quaternary structure. So, diba na, ingana lang ka-simple ang structure sa protein. Walay dapat i-complicate nga mga butang. Pag isabton lang yun nato ang mahitabo during the structure or each structure. So kung primary, line up, secondary, alpha helix and beta pleated sheet, pag tertiary, 3D, and pag final na yun niya is, again, naka 3D gihapon, pero final na or wala na siya pwede mo sab 3D lang, 3D gihapon siya. So those are the structures of proteins from sa pag-line up down to its final structure, the quaternary structure. So siguro dili lang ta mag-end, continue lang ta with the protein classification based on shape sa next na po na to nga discussion. So that's it for this morning. Thank you very much. And sa mga katong mga wala kaayo correlate sa atong gina-discuss or ginabasa sa atong handout, so magbasa na kita. So that's it for this morning.